All right, so the calculator that I'm using up here is the TI 36X Pro that I recommended to y'all that does the nice complex calculations. If you don't have a calculator that does good complex calculations yet, it is, you need to have one because it makes a big difference. As you'll see as we work through the problems. When I took this class, I don't know why, but I really have no idea why, but I did often, work all the problems out, doing all the complex calculations by hand, which I don't know why I did that. Because I had a good calculator.
Did you post the worksheet on Moodle?
I thought I did. Is it not there?
It should be under Circuits 2, the SI resources.
Yeah, Circuits 2 SI resource at the top. I moved it to the top to try to be helpful, and apparently that was not helpful.
I think it's just instinct to scroll all the way down.
What's that?
I think it's just instinct to scroll all the way down.
Right. Usually, let's see, why am I not able to? There it is. Okay.
So the TI-30 is like really all we would need for this class, or do we need like a higher capable calculator?
For this class, no. So the TI-30, even though it says 30 there, that's the European version. In the US, it's 36.
Yeah, that's the one I have.
Yeah. No, you really don't. Because I don't use the 84 for anything other than graphing anymore. If I want to do fancy stuff, I use the Inspire CAS or an 89 titanium, but that's just like, that's really really extra. I mean, you don't really need that, but for this class, this is all you need. So I'm quite fond of it. Okay, so I'll start with problem 1, unless y'all have questions for me before we get started. All right. Okay, so this first problem, you'll see that in the next chapter, you will sometimes have to come up with impedances that make your circuit do a certain thing, and this is just kind of introducing you to that. It's saying we have a circuit here, and the impedance, when the impedance is real, that you have optimum performance. And so we have to add something to the circuit. So it's like the circuit is already built. So this is a design problem, and this is the circuit. But it'll perform better if we add something to it that will make the impedance completely real. So we need to figure out what that is. So we'll start by changing all of these things into the phasor domain. So I is going to equal 2 angle 0 because there's no additional phase. Now notice V of S, Vs of t, that's a sine, and so it equals 8 cosine. So before I change it to a phasor, 8 cosine 1000 t minus 90 degrees. So as a phasor, that would be 8 angle negative 90 degrees. Or if I wanted that in rectangular form, negative 90 degrees is going down this way to the imaginary axis. So that's minus j. So V equals minus j8. So these two are the same. So I have those values. So this current, I can say, is 2 angle 0. And then I can combine my 6 ohm resistor and my 4 millihenry inductor. So looking at I and S up here, I see that omega is 10 to the third. So omega is 1,000. And so my inductor becomes, the phasor version of it is going to be J L omega, which would be J times 4 milli, so milli is 10 to the negative third, times omega, which is 10 to the third, or just J4. And then I'll add that to my 6 ohm resistor, which is real. So this is J4 plus 6. And then my capacitor is, minus J over omega C. So that's minus J over 1,000 times 0.5 times 10 to the negative third, or minus J over 0.5. So minus J over a half is the same as minus J2. So my capacitor is minus J2. And then I see that my next branch here has a voltage source and a resistor on it. It would be easier for me if I could change this to a resistor and a current source, doing a source transformation, because then all my elements would be in parallel. And so I can do that. So I'll do a source transformation. So a voltage source and a resistor in series become a current source and a resistor in parallel, or an impedance in parallel. And so the resistor is just a resistor. It doesn't change. It's 2. And then I use V equals IZ to find out what my current source should be, or I equals V over Z. And V was, it was minus J8. Minus J8 over 2 is minus J4. So this is now minus J4. So y'all stop me if you have any questions. All right, so current sources in parallel, I can just add those. 2 angle 0, that's just a real number, that's 2. And so I've got 2, the real 2 and an imaginary minus J4. So I can add those together and just get 2 minus J4 is now my current source. And then I have all of these impedances that I can combine because they're in parallel. But I've got 3 of them, so I can't do product over sum with 3 of them. Right now I'll just call that Z, Z equivalent. And I'm still going to add some Z in here to answer the question. That's my unknown. But my Z equivalent, since I've got 3 of them, I can't do product over sum. But if you remember, if I had 3 resistors in parallel, where that was R1, R2, and R3, the equivalent resistance is 1 over R1 plus 1 over R2 plus 1 over R3. And I can do the same thing with my impedances. So I can say my equivalent impedance is 1 over J4 plus 6 plus 1 over minus J2 plus 1 over 2. And this is where sorry. It's like I was moving, like I moved this as if that would help you see. So I will do, on my calculator, I'll use the fraction button, and I'll do 1 over, and then the fraction button again, 1 over J4 plus 6, and then plus fraction button 1 over minus J2 plus, I'm going to do 0.5 by putting a decimal in there. If I put any decimal in there, it'll give me my answer in terms of a decimal instead of a fraction, so which often is helpful. So my Z equivalent is 1.103 minus 0.7 minus, then that's the imaginary part, minus J.759. Or I can change that to polar, so I can do second complex change to R angle theta, and I get Z equivalent is 1.339 angle negative 34.5 degrees. Okay, but I did something wrong? What did I do wrong? I have a minus, no, that's right, that's right. Did I type something in wrong up here? No, I didn't do anything wrong. I didn't do anything wrong. Okay, so if I change this back to a voltage source, my voltage source would be, is that a 2? 2 minus J4? Yeah. 2 minus J4 times my impedance, which is, I'll just say 1.34 angle negative 34.5. So that would be my voltage source. And then my impedance, 1.103 minus J.76. And then I want to add some other impedance in here in order to make my total impedance real. Now, I don't actually need this voltage over here, but just to be complete, I'll figure out what it is. So I'll take this number that I currently have in the calculator, which is the impedance, and I'll multiply that times, in parentheses, 2 minus J4. I'll change that to polar. Is about 6. So 6 angle negative 97, negative 98 degrees is my voltage source. And then it's very easy to see what my impedance needs to be that I need to add in order to make this real. In order to make this real, I need to make the imaginary part go away. Well, the imaginary part is negative J.76, and so I need to add a positive J.76. So I need a positive J.76, and then if I were to add those two together, then that would give me a purely real impedance. So that's what I need to add. Now, is that going to be an inductor or a capacitor? what I'm adding in right here. It's positive, right? Remember, inductors, when you change them, they are L omega J, or J L omega, and capacitors are minus J over omega C. So which one is positive? Quote positive, it's an imaginary number, so positive and negative doesn't mean anything, but it'll be an inductor. Okay, so we want an inductor, and we want JL omega to equal J.76. So now we're finding out, we know it needs to have an impedance of J.76, but for our particular circuit, we're saying, well, what inductor do you go pick out of the box for this? So JL omega has to equal J.76. The J's will cancel. L is what we're solving for. L times 1,000 equals 0.76, or L equals 0.76 divided by 1,000, or 0.76 millihenries.
So did you choose inductors out of convenience because it turns out real nice, or could you have gone either way?
No, I could not have gone either way, because otherwise I would have ended up with a negative capacitance, and you can't have a negative capacitance.
Right.
So I chose the inductor because it was positive. If it had been a capacitor, I would have chosen a negative. I have a calculator that's the same color. Do you need to show me how to need me to show you how to do anything on the 84?
I don't think yet.
Okay, all right.
I was going to ask how you got the angle with that calculator. Like,
Yes.
Bring the imaginary to the angle.
Okay, so the easiest way, and does anybody want me to go get a calculator out of my office for you to use while we're in here to practice on? Because I have several. Okay, so 5, and when I get to problem 3, y'all are going to have to work it out, because I don't have it worked out, so you'll have to check me. So if I have a complex number in there, I can't just from here change it. I either need to put it in parentheses or do what I'm going to do next, and that'll make it easier. So here I have the complex number. Now that complex number is my previous answer. So now if I just go straight to my complex number menu, it'll pull it up as answer, and so I don't have to put it in parentheses. If I did it from where it was at 5 plus J8, it would just change the J8 if I didn't put it in parentheses.
Okay.
So, but here, since it was the previous answer, I just go to second and complex, and I go down to number 4, and that says change it to R angle theta. And then it gives it to me. And,
I see. Okay.
yep.
Yeah, I didn't know it went down further than the first 3.
Yep. And then you can also get, like I could do polar angle. If I just wanted to get the angle, I could do polar angle. And it would tell me just what the angle part was. Now, on the 84, which the 84 is not as great with doing the polar stuff, but so if I had 5 plus second I6, enter, and then it's in the math menu, and over to complex, and go down to number 7, polar, and it'll give it to you 7.8 e to the whatever, and that angle, depending, is it always going to be in radians? I think it might always be in radians. Let's see, I'm currently in radians. Let's see what happens if I change it to degrees. No, it gave it to me in degrees. So if you're in degrees, it'll give it to you in degrees. There is something that it does where it only will do it in radians, and I can't remember what it is. But did you get yours to work?
Yes.
Okay.
If you
All right.
don't mind, on the second set, could I borrow one of those TI 30s?
Uh-huh. Yeah.
Appreciate it.
I'm going to stop this recording and save it, and then I'm going to go. This is really good because I came over here. I really need to go to the bathroom, so I'm going to do that.